Hey everyone. We have quite a bit to go over this week. We have an exam on Wednesday. We still need to revisit Lewis structures. We need to talk about electron configuration a little bit more. We need to talk about atomic structure and calculating average atomic mass. So quite a bit to get through before our exam on Wednesday. And so it's really important. I ask you that you take out your composition book at this point, write down notes, make sure that you have everything together for your exam on Wednesday. All right. Let's start with Lewis structures. I'm going to break this video up into several different videos. This one is going to focus on Lewis structures. And we started talking about Lewis structures on Friday. I explained to you that Lewis structures focuses on valence electrons. Those are the outermost electrons that are responsible for bonding. That's a definition. I'm going to repeat it. Valence electrons are the outermost electrons responsible for bonding. All right, so how do we know how many valence electrons an element might have? All right, we're going to use a periodic table to do this. We're going to start with group 1. Group 1 elements have, I can get my highlighter to work, have 1 valence electron. 1 valence electron. Group 2 elements have 2 valence electrons. Not sure why that came out in yellow. Let me try again. 2. We skip this D block group for labeling valence electrons because, well, there are several reasons. We could talk about how these elements are not structurally sound and how they start moving other electrons to get to a more stable point. We could talk about that with this group as well. Even this one. We're not, just ignore everything I just said. And for the sake of trying to understand valence electrons, we're not even going to include these guys here. Why? Because they have many, like at any given point, even one element like iron could have different valence electrons. So we're going to move on to this group and say that the boron family has 3 valence electrons. And I'm going to highlight that. Carbon family has 4. Nitrogen has 5. Oxygen family has 6 valence electrons. Fluorine has 7. Halogens, with the exception of helium, which only has 2, has 8. When we're drawing Lewis structures, which is our focus here, in 8th grade you drew Bohr models. In high school chemistry, we draw Lewis structures. We're focusing simply on valence electrons. None of our practice problems are going to include transition metals or even the F block. We're not going to include those. We're going to try to keep this as very mainstream and simple as possible. Let's start with a group 1 element, and let's maybe look at lithium right here. And I can't get to it. Lithium. Lithium has an atomic symbol, Li. When we're drawing Lewis structures, we first start by writing the symbol. So steps. Step 1, write symbol. All right, so we're looking at lithium. We're going to do the symbol for lithium, which is Li. And looking at what group it is part of, we see it has one valence electron. It's part of group 1. And when we're really trying to determine valence electrons, we're honestly looking at the number next to the letter A. I know it's kind of hard to see from here. If you look at the alkaline earth metals, there's 2A. We skip transitions because I already crossed them out. Then we get over here and we're 3A, so all of this family has 3 valence electrons with a couple without some of these guys here. Group 14 have 4 valence electrons, 15 have 5, 16 have 6, 17, group 17 have 7, and group 18 have 8. You have to memorize this. There aren't a whole lot of things that you have to memorize in chemistry, but this is one of them. Valence electrons, looking at a periodic table. All right, lithium has 1 valence electron. And so when we're drawing Lewis structures, we kind of assume 4 points. And please, when I'm about to write, do not write this when you're writing Lewis structures. I'm only writing this because I want you to know where the dots go. There's a section up above, on the side, down below, and on this side. You would never, in a Lewis structure, draw those lines I just wrote. I only drew those lines so that you would know what my direction is. Okay, do not draw the lines. That is not part of a Lewis structure. All right, I just erased those lines so you would not get confused. But I had to draw those lines so you would know where your valence electrons would go. Again, lithium is part of group 1 elements. It has 1 valence electron. So I'm going to start at the very top and I'm going to draw 1 valence electron. This whole thing right here is the Lewis structure for lithium. If I went a step down and we looked at sodium, Sodium's Lewis structure, we start with the symbol Na, has only one valence electron. I would draw the Lewis structure for sodium like this. If I went another element down to potassium, the Lewis structure for potassium would start with the atomic symbol of potassium, K. Then I would draw the electron, the one valence electron that it has, and it would go right here. If you notice, every single element in group 1, lithium, let me start over here, lithium, sodium, potassium, are all part of group 1 alkali metals. They're in the first group, and I wrote they have one valence electron. Every single Lewis structure looks exactly the same because they all share very similar chemical properties. Let's look at alkaline earth metals. Alkaline earth metals are group 2. We can start with beryllium. Beryllium symbol is Be. It is part of group 2 alkaline earth metals, which means it has 2 valence electrons. So the way we would draw it is 1, 2. The next element in group 2 is magnesium. We would start the Lewis structure for magnesium by drawing the symbol, which is Mg, and the valence electrons would go 1, 2 on the side. It's part of group 2, right here, has 2 valence electrons. Let's skip over to nitrogen. Group 15, 5 valence electrons. We start first by drawing the symbol for nitrogen, which is N. Then we will draw the 5 valence electrons, which is 1, 2, 3, 4. Now we're all but maxed out, and we have to double up electrons and orbitals. So we're going to draw the last 5th valence electron doubled up here on the top. What does this mean? This Lewis structure tells us quite a bit. First of all, we call this a lone pair, and it occupies a very large space, quite a bit of space. But what this also tells us is that bonding can still occur here, on here, and here on nitrogen. So although nitrogen has one lone pair where no bonding can occur, it can still form 1, 2, 3 different pairs of bonds. That would be the same for any element in group 15. Let's skip ahead some more and go to the halogens. And I'm going to draw the halogens in this area. Let's look at neon. Drawing the Lewis structure for neon, we're going to start first with the symbol. Neon is Ne. According to our periodic table, it has 8 valence electrons. So we're going to draw those 8 valence electrons, starting at the top. 1, 2, 3, 4, 5, 6, 7, 8. If you notice, and from what we just did from nitrogen, we have 4 lone pairs on all sides. What does this mean about neon? It means that under normal situations, neon is not able to form any kind of bond with any other element. This is why we use Lewis structures. Again, I said this at the beginning. In order for us to understand the bonding capacity for an element, we need to look at the Lewis structure. Now, I say that, but there are always exceptions. A good exception to kind of highlight kind of starts here with xenon. Xenon is able to do some other things with its valence electrons, and we don't need to get into that right now. But my point is this: we use Lewis structures to understand bonding capacity. Elements in group 8 typically do not have the ability to bond with any other elements because they're already bonded. They already have two electrons in their electron orbitals that it has. So bonding cannot occur there. All right. Recap real quick. Lewis structures show us bonding capacities of elements by looking at their valence electrons. You need to memorize that group 1 elements have 1 valence electron. Group 2 alkaline earth metals have 2 valence electrons. Boron family have 3 valence electrons. Group 14 have 4 valence electrons. Group 15 have 5 valence electrons. Group 16 have 6. Group 17 have 7. Group 18 have 8, except for helium. And Lewis structures show us, when we draw them, how many bonds an element can form.